Now, so far we've defined a random experiment as one whose outcomes are in practice unpredictable. And remember, random here focuses on the unpredictability. It doesn't mean reasonless. The set of all possible outcomes is the sample space. A set of some of the possible outcomes is an event. And the event occurs on one trial of a random experiment if any of its outcomes is the result of the experiment. So again, only one of the outcomes has to actually be the result. Notice that we haven't yet defined an important term. What is probability? Now, there's actually two important ways to interpret a probability. The more common is known as the frequentist interpretation. If the probability of an event is p, then the event will occur with frequency p. If the probability is 1, the event will occur 100% of the time. Meanwhile, if the probability is 0, the event will occur 0% of the time. Otherwise, the event will occur some intermediate fraction of the time. For the frequentist interpretation, a probability 1 means the event will occur 100% of the time. In other words, it will always occur. Likewise, a probability 0 means the event will occur 0% of the time. In other words, it will never occur. So, what does this really mean, though? Suppose you flip a coin and record how it lands. It will land either heads or tails. We'll assume it isn't carried off by an eagle to Canada. So, let's assume the probability it lands heads is 0.5. This means it will land heads 0.5 times 150% of the time. But will it? Suppose you flip the coin one time. It can't land heads 50% of the one time. It either lands heads or it doesn't. If it lands heads, then it's actually landed heads 100% of the time. And if it doesn't, then it's landed heads 0% of the time. So what does it mean that it will land heads 50% of the time? Well, suppose we flip the coin a second time. Since we flipped it twice, it could land heads half the time. This means one time the coin lands heads, and the next time it lands tails. Or does it? Suppose it lands heads on the first time. In order to land heads half the time, it must land tails the second time. But remember, it's a random experiment. The outcome should be unpredictable. So we just made a prediction of what it must do, and that speaks against it actually being a random experiment. So if it's a random experiment, we don't know how it will land tails the second time. It might land heads again. Equivalently, if it lands tails the first time, it does not have to land heads the next time. And even if it did, how can it land heads 50% of the time if we flip the coin a third time? This is the concept behind the law of large numbers. The probability of an event is the frequency provided you perform enough trials of the random experiment. Otherwise, it's only an approximation to the actual frequency. For example, if you flip a coin 1,000 times, then if the probability of the coin landing heads is 0.5, then the coin will land heads about 50%, that's 500 times, and it will land tails about 500 times. But that's just an approximation. Don't be surprised if it lands heads 490 times or even 410 times. These predictions should be viewed as approximations to what you'll actually observe. While the probability must match the actual frequency if enough trials are performed, enough is usually far more than we're willing to perform. The idea that the probability and the actual frequency have to match if only a few trials are performed is known as gambler's fallacy. So, for example, you see someone flip a coin 9 times and it lands heads once and tails 9 times. And so they tell you, well, since the coin only landed heads once, It's got to land heads a bunch more times to make the probability of landing heads equal to 50%. So, want to bet $20 that the next time it will land heads? The frequentist interpretation really only works if we can repeat our random experiment, but sometimes we can't. You can't run tomorrow's weather again, so what does it 80% chance of rain mean? Or sometimes we might reconsider. If someone flipped a coin and made it land heads once in 9 times, maybe they can control how it lands, and maybe we shouldn't bet $20 on the outcome. This leads to what's called the Bayesian interpretation. The probability of an event is a measure of how confident we are that it will occur on the next, and possibly only, run of a random experiment. Probability 0 means we're confident it won't occur. Probability 1 means we're confident it will occur. And a probability between 0 and 1 means a greater or lesser degree of confidence. There's one important difference. Under the frequentist interpretation, a probability 0 event can't occur. It occurs 0% of the time, never. Under the Bayesian interpretation, a probability 0 event is one we're confident won't occur, but we might be confident it won't occur, and it might still occur anyway. Probability 0 does not mean impossible. And by a similar argument, a probability 1 event isn't guaranteed. With a Bayesian interpretation of probability, we can assign a value to a probability that gives us a starting point. So for example, let's try to assign a probability to the events. You'll watch to the end of the video, you'll send me $1,000 to support my effort, and you'll pass the class. Now since you're almost at the end of the video, I'm pretty confident you'll watch to the end, so I'll give this a high value like 0.99. I'm very confident you'll want to send me $1,000, maybe even $10,000. But since you don't have my address, I'm pretty confident it won't happen. So that's probability 0. Again, it's not impossible, but I'm not going to wait for a check in the mail. As for passing the class, if you do the work and put in the effort, you'll probably pass the class. But sometimes you won't. Things happen, life gets in the way, so maybe some sort of intermediate probability like 0.8. Pretty confident, but not absolutely confident.